Here we look at free radical substitution. And in a free radical substitution mechanism, what happens is that a chlorine is added to either an alkane or, as we'll see later on, a halogenoalkane. The simplest reaction is the reaction of methane with chlorine. And what's going to happen then is that simply one of these hydrogens in methane is going to be replaced by one chlorine. And we get that as my overall reaction. Substitution, because one of these H's has been replaced by one of these chlorines. Now, what we need to look at then is the mechanism, the step-by-step process of the bond breaking and bond forming in this reaction. And the first of these steps is called the initiation step. To initiate means to start off. And in the initiation step, we need to break a bond. Like in any chemical reaction, the first thing you do is break bonds. And the bond which breaks is the bond between the chlorines. And that bond breaks because it's the weakest bond. It's weaker than a carbon-hydrogen bond. Now, what's happening here is that this bond is going to break homolytically. It means when the bond breaks, both atoms in the bond get the same number of electrons. So one electron in the bond goes to that chlorine, the other electron in the bond goes to that chlorine. We end up then with two chlorine atoms. We call these free radicals. So this dot here is representing a free radical, which is just simply a species with an unpaired electron. Now, in order for that bond to break, we need UV light. The UV light provides the activation energy to break that chlorine-chlorine bond. Once we get these chlorine radicals, the reaction can continue, and we get the next step, which is something called a propagation step. To propagate means to grow. And you'll see that propagation occurs in two steps. So propagation step 1. And what happens here then is that the methane, my other reactant, reacts with this chlorine radical. Now, what's happening here is that this electron here and one of the electrons in this bond is going to be used to form a new bond between the hydrogen and the chlorine. So in effect, this electron here and one electron there, that's going to form a new hydrogen-chlorine bond. The other electron is going to go to the carbon and form a new radical. So we get then a CH3 radical plus HCl. And we've got to remember that the first propagation step will always form HCl if you're adding chlorine, if your halogen is chlorine. And let's just go over it again. That this electron here, or one of the electrons in this bond, are now here in this bond between the hydrogen and chlorine. So one electron from that electron, the chlorine, one of the electrons in that CH bond now are here. The other electron in this bond is now there, and that's my radical. Now, in a propagation step, we have to remember that we have a stable molecule plus a radical gives another stable molecule and another radical. That's what occurs in propagation. Stable plus radical gives another stable plus radical. So let's have a look at propagation 2. So I form one of my products. So if you just go back to my reaction, HCl is one of the products. We form HCl in the first propagation step. We now need to show how we form this chloromethane. Now what happens is this methyl radical, which I'm going to just write down as like this, reacts with another chlorine molecule, Cl2. And what happens is that this electron here and one of the electrons in this bond is going to form a new carbon-chlorine bond. So this electron there, and one of the electrons here is going to form a new carbon-chlorine bond. The other electron in this bond is going to go to the chlorine and reform a chlorine radical. So what we get then is we get my second product, CH3Cl, and we reform my chlorine radical. So that's my second propagation step. Now if I add up my two propagation steps, I should end up with my overall reaction. So whatever appears on both sides, if I add these two steps up, these two propagation steps up, and we cancel what appears on either side of the equation, we should end up with the overall equation. So let's just have a look at that. So if I cancel these two, and I cancel these two, then we have the reaction CH4 plus Cl2 gives CH3Cl plus HCl. Now, there is a termination step in this reaction as well. And the termination step occurs when any two radicals combine. And they will usually tell you what product they want you to form. So outline a termination step for the formation of a certain product. And an example would be two methyl radicals, for example. They could combine and they would produce ethane. So what's happening is that this electron here and this electron here, they both combine together to form a new carbon-carbon bond. So that's your termination step. Now, once this chloromethane here has been formed, if there are any chlorine radicals still around, which there's a high possibility there would be, this chlorine radical here is not going to discriminate what it pulls that hydrogen off. And this is when we end up with something called multiple substitutions. Now what that means is that this chlorine radical, not only can it pull hydrogen off methane, as it's doing in this step, but it can also pull a hydrogen off chloromethane. So in effect what we can get then is this reaction. Okay, now if we were to look at the mechanism for this, the initiation steps obviously going to be the same. The propagation steps now would be as follows. So I'll just call this P1. You'd have a CH3Cl, and again what you've got to remember is the chlorine radical here always pulls a hydrogen off to form HCl. So what you would get then is this chlorine radical is pulling one of these hydrogens off, and we end up then with a CH2Cl radical plus HCl. Then this radical always then reacts with chlorine in the second propagation step. So P2, that reacts within chlorine, and that produces your CH2Cl2, and again reforms your chlorine radical. Now this can keep going as long as the hydrogens pull off. This can keep going. So obviously this here can react with chlorine, and that will potentially form then CHCl3. Again, this CHCl3, that's got a hydrogen, and again that could potentially also react with chlorine to give CCl4. So in these reactions of methane and chlorine, potentially what we could form is chloromethane, dichloromethane, trichloromethane, or tetrachloromethane because of these multiple substitutions. And that is an outline to free radical substitution.